All right, good afternoon, everybody. Thank you for joining us here at Pragmatic Works for our training on the T's. I guess it's training on the T now since we just do it on Tuesdays. My name is Mitchell Pearson, and in this session what we're going to do is we're going to have a discussion about data modeling, but we're going to be more specific and focus really on just the designing of the dimensions here. If you want to contact me, you can contact me at my email address. It's ilmpearson@pragmaticworks.com, and I'll try to put that up here at the end of the webinar as well. If you've attended any of my webinars in the past, then you know that I usually try to cover a lot of material and usually don't have a lot of time during the webinar to answer questions, but I always, almost immediately within the same day, I will get as many questions as I can and respond to them via my blog post. So do look for that after the webinar if we don't have time to get to your question today. All right, a little bit about myself. My name is Mitchell Pearson. Once again, I am a business intelligence consultant and trainer for Pragmatic Works. I've been with Pragmatic Works now for about 4.5 years, just over 4.5 years, I believe. And I blog at mitchellpearson.com, and you can also follow me on Twitter at MitchellSQL. And like I said a moment ago, I've done a lot of presentations for Pragmatic Works in the past. I've done a lot on T-SQL, MDX, SSIS, SSAS, and I've also done a webinar in the past on data modeling with one of our old consultants here, Dustin Ryan. Not old as he is old, but he used to work for us kind of old, if that makes sense. But Dustin Ryan and I did one a while back, and it was on data modeling from the ground up, and we covered all the fundamental basics of data modeling. And we got a lot of questions from that, which really told us that, hey, we needed to have a dimensional modeling class here at Pragmatic Works. And a lot of the questions revolved around dimension design. How do we design the dimension for those slowly changing dimensions, and so that they are maintainable over time? So that's what we're going to focus on here in this webinar. All right, so the fundamental kind of 4 steps to dimension design are defining the business process, declaring the grain, dimension design, and then fact table design. And obviously in 1 hour we don't have time to review all of those, but we do in the new class that we just released. Today what we're going to do is we're going to focus on dimension design. So on dimension design specifically, how do we design those dimensions, what is the architecture of those dimensions, so on and so forth. All right, so Ralph Kimball defines dimensions as dimensions provide the who, what, when, where, why, and how context surrounding a business process event. And what we mean by that is if I came to you and said, hey, I have $5 million in sales, then you would start asking questions about that. You would say for what year, for what month, for what store, for what product, so on and so forth. And all of those questions that you ask are typically attributes that we store inside of dimensions. So dimensions explain our data. So that's what we're going to be kind of going through here as we define our dimensions. The agenda for today is first we're going to talk about the overall architecture of a dimension table. What does that look like as we're designing that out? So we're going to discuss surrogate keys. We're going to look at the dates. Why do we have date attributes in our dimension tables? And then also flags. We're going to discuss the 3 main types of dimensions, so type 0, type 1, and type 2, the differences between those and when you want to use them. We're going to talk about many dimensions. Many dimensions fit right in with the different dimension types, and especially slowly changing dimensions. And from the survey, it looks like about 87% of you have a need for slowly changing dimensions, so this will be great to cover here in this webinar. And then we're going to talk a little bit about many-to-many relationships between dimensions and a couple different options that we have to model that. Now, you could do an entire course on just many-to-many dimensions and how to model that and all the different methods available, but we're going to talk about a couple of them here at the very end of the webinar, should we have time, and we should. All right, so once again, the 4 things we're going to cover here: architecture, the different types of dimensions, many dimensions, and then many-to-many relationships. All right, so when we're looking at a dimension table, the dimension table is derived from our transactional system, and in our transactional system, which is designed, transactional systems are normalized, meaning they're designed for inserts and updates. So if I look at my transactional system, if you've ever built a report off of your transactional system, you typically, if you want to get customer information, for example, you have to do a join between 10 tables or 15 different tables just to get the phone number and the email and the address and so on and so forth. And it's because the transactional system is normalized. Well, when we build our dimensions, we build our dimensional model, we go back to the transactional system and we denormalize all of that. We take all those attributes that we want to be combined inside of our dimension table, we join them all together, and we have one table for our customer dimension, for example. And that table is typically going to be quite wide. And the reason it's wide is because we have a lot of different columns in it, because now we have the phone number, the email, the address, the age, the gender, everything about that customer now exists in one table, which is going to make doing analysis and building reports significantly easier than it would be off of a transactional system. Now, it's a wide table. They're typically not very deep like your fact tables. We won't get into fact tables today, but fact tables, on the other hand, are typically very deep, meaning there's a lot of records in them. But with our dimensions, we typically won't have that many records. We're going to talk about surrogate keys here in just a moment, so I'm just going to jump over that one. So we'll have two kind of keys in our dimension. We'll have our surrogate key and our natural key. Our natural key is the way that we tie our dimensions back into our source system. So we use that for validation to make sure that everything is working correctly. We use that to be able to go back and do some analysis to make sure everything's coming in correctly. So kind of in the same lines as validation. But we'll always have that available in our dimensions. We use that for lookups during the ETL process as well. The surrogate key is unique only to the dimensions and has no relationship back to the transactional system. When you're building the dimensions, especially your dimension architecture, you're building out those dimensions, one thing I want to point out here is that the best attributes are going to be descriptive. And what I mean by that is you shouldn't have a lot of codes and cryptic abbreviations that you're storing in your dimension tables. When you put those codes and abbreviations in your tables, your end users don't know what they mean, and now they're having to go back to other tables and try to decipher those different codes, or you walk by their desk and they got a bunch of sticky notes all over their computer. And if that's the case, then you haven't quite designed that dimension the correct way. We need to go back and revisit that. So the best attributes are going to be descriptive. Replace those codes with actual descriptions of what they mean so that when your end users are consuming your data model and they're doing analysis, they're going to get the best possible interaction with that data model. All right, and then our dimension models will typically have start and end dates, and this is to support things like tracking changes over time for our slowly changing dimensions. Now, I typically will only put a start date and an end date in the dimension table if I know it's going to have a type 2 dimension, which we'll talk about here in just a moment. I know some dimensional modelers who are phenomenal at what they do. They might build their dimension from the very beginning and just add the start and the end date in there from the beginning, so if they ever decide in the future they're going to change one of the attributes to a slowly changing dimension, they already have the structure in place and they don't really have to go back and change their ETL or any of that because everything's already been built in, which is a very neat concept. Typically, I will only add them if I need them. And then a lot of times we'll have these flags that we add to our dimensions, and these are simply just true-false values or Boolean values that allow us to be able to do some quick analysis and see some information. For example, you might be looking at your date table and you have something like is holiday or is workday. Or on a dimension table, we might add a flag for is this the current row or is this row active? Because as we expire rows, only one row is going to be an active row. So we might have a flag that we add that makes bringing in only the current records a lot easier when we're writing our queries. All right, so let's talk a little bit about surrogate keys. I've done this talk about surrogate keys many, many times, and a lot of people kind of get caught up here and get lost. So hopefully, by the time we get done with this quick demo here, it'll be pretty clear to everybody on what we're trying to do. The surrogate key is a unique identifying column that's generated in the data warehouse, so in the dimensional model, in the dimension table that we're creating, that has no relationship back to the source system. Now, the main question around that is why do we create these new keys, these new IDs, instead of using the natural key from the source system? And there's a lot of reasons, but there's two main reasons I'm going to talk about here in this webinar. The first one is that it insulates you from source changes. So for example, if two businesses merge and the natural key in those two different businesses change, meaning that the natural key goes from being an integer to maybe an alphanumeric character, that could have significant impact on your dimensional model. So we'll talk about that in a moment and how we model that. And then it also allows for historical changes. So not having that surrogate key there means that the natural key can't be duplicated in that table because then it violates the primary key constraint. So the two things we're going to talk about here are going to be insulates us from source changes and then allows for historical changes. Now, there's three different types that we want to talk about when we're talking about dimension types. The first one is going to be a type 0. A type 0 is a fixed type. It's a non-changing attribute. So when we're talking about types, when we go through type 0, type 1, and type 2, it's important to understand that if you have a dimension and dimension has 20 columns in it, that some columns can be type 0, some columns can be type 1, and some columns can be type 2. They don't all have to have the same type on them. So when we look at individual attributes in a table or individual columns, we identify what their type is going to be. So for example, if it's a type 0, it means it's something like a social security number or maybe a date of birth or something like that that we know should not change over time. Now hopefully we don't have a social security number in our dimensions, but that's just an example of what a type 0 might be. And what happens with a type 0 is if it changes, if we're doing our ETL process and we notice that the social security number, for example, changed, then we just ignore that change, or we fail the ETL process that's taking place, but we don't make any change to the actual attribute or the actual column in the dimension table, regardless of what happens in the type 0. A type 1 is a changing attribute. So that means if Kim Williams gets married and she changes her name to Kim Smith, we change her name in the dimension to Kim Smith, and we never can go back. Now, we can never go back in the past and say, okay, well, how much did Kim Williams purchase when her name was Kim Williams, and how much did she purchase from us when her name is Kim Smith? We can no longer do that type of analysis because we're only doing type 1, which means we change the attribute in place, we change the record in place, we don't keep history, so we can't go back and compare the difference. Type 2 dimensions are the most complex by far. It's going to add the most complexity to your ETL processes. And this allows you to keep historical changes over time. So we can keep historical changes over time. A good example here might be something like a list price on a product. So I sell a bike for $300, and as of January 15th, we changed the price to $350. We want to be able to go back and do analysis and say, okay, when we change the price, did we sell more bikes? Are we making more profit overall? Even we're selling less bikes, but we're making more profit overall. How did that price change affect accessories and other things in our organization? So we'll go back and we can do that with type 2. So when we add these, even though they're more complex and it's more administration on our part and more complexity in the ETL, it gives us more analytical value within our dimensional model. Liz, did you have a question? I'm getting a little bit of feedback here.
Nope, I'm on mute. I was on mute, so I don't know where that's coming from.
Okay. So let's walk through each of these dimension types in detail here and walk through a quick example. So this is a type 0. So Susan's information is populated in the dimension for the first time. We pull the data in from the transactional system and we insert a record into our dimension. And then Susan calls up, and Susan calls up to our call center and says, hey, I changed my name to Taylor, I got married, I'm really excited about it. Please go ahead and change my name in your system so when you ship stuff to my address, it has the correct name on it. However, when we go to load our dimension at night and we bring in the new information that her name is Taylor, what we're going to do is we're going to ignore that change, and in our dimension table, it's going to just stay Susan Smith because we don't really care if people are changing their last names. It has no analytical value to us whatsoever, so we ignore it. All right, so that's what a type 0 is. A type 1, remember, that is where we keep history. We keep history, or we don't keep history. We change the attributes, but we don't keep any history at all. So once again, if Susan calls in and she calls our call center, she changes her last name to Taylor. When we run our ETL process that night that reads from the transactional system, it picks up that she changed her name. It compares it with the dimension and says, okay, we noticed that there's a change. What do you want me to do with it? And then we change the existing record the way it is. So now we can actually look at, if we're doing analysis there and we're bringing in her name into a pivot table or something like that, or into a report, we can see Susan Taylor purchased $10 million from us. Hopefully we got customers that have that much money, right? Susan Taylor purchased $10 million from us, but we can't go back and tell if she's purchased more since she got married or less. There's no way that we can go in there and really look at that. And then somebody asked, is she still single? Well, she might be. Maybe she changed her name there, but didn't want to get married. All right, so new data shows Susan's marital status as well. So this is another example of a type 1 where we go in there and change it again. So maybe it happened in 2 separate processes, and now she is married. All right, so she called up and she told us she changed her first name, but she didn't tell us she was married. All right, on the type 2 here, notice that we have a couple different things here. We now have a start date and an end date that we've added to our table. We'll come back to that in a moment. And what happens is when Susan Smith calls us up and changes her name and we go to load our ETL at night, we have to come into our type 2 dimension. We have to expire that old record, which was Susan Smith, and then we insert a new record into our dimension table, and that new record has an end date of null. Now remember that I said sometimes these dimension tables will have flags, and you might have a flag column here that has a 1 value that says, okay, this is the current record. And all of the older records that are expired, they might have a flag or a value of false, right, or a value of 0. So that's how we would build this out here. So sorry I'm talking so fast. I'm trying to make sure I get through all the information I'm cramming in this webinar for you guys. But this is an example of a type 2. All right, so we can go in there, we would enter a new record, and if her record changes again, if she calls up and says, hey, you forgot to put in there that I'm married, or I forgot to tell you that, then we would expire that record again, and then we would keep a record of when she got married. So now we have 3 records in this table, okay? So that's a type 2 dimension, and that's kind of how we model that. All right, so we're going to go into Excel real quick. We're going to walk through a very simple demo of the different dimension types. Really surrogate keys is what we're going to do here. We're going to talk through surrogate keys and how having these surrogate keys help us from the perspective of insulating us from source changes and also being able to keep history over time. So the first thing I want to add in here is just a couple columns. So we're going to have a product ID, we're going to add in a name, and then we'll add in a color, and this is just going to be a product dimension that we're going to create here. All right, we'll add in a color, let's go ahead and throw in a weight, and then we'll add in a list price. Now this is going to be our source system. So just imagine in my source system here that what we have is a bunch of kind of different tables that we've denormalized, we've brought them together through joins, and we have all the attributes here in one view. And then we can give these some values here, right? So I'm just going to throw some numbers in here real quick. Something like product ID, and this will be a bike. The color of the bike will be red. The weight is 12.5, and then the list price is $357. All right, so the numbers that we're throwing in here really don't matter that much. All right, and now in my source system, this is the primary key in my source system. This is that kind of logical key to the business. So let's put that in there, primary key. Then we'll make that red so it stands out. And then what we would do from this is we would start designing our dimensional model or our dimension table for our products from our source system. So we'll have a lot of the same columns here. So I'm going to add in a product ID. I'm going to add in a name. Really, I could probably copy everything. So let's just copy everything down real quick. All right. And as of now, if we're not using surrogate keys, as of now, this is going to be my primary key in my dimension table. And for this first example, we're going to walk through how surrogate keys help us with tracking historical changes over time. So now I have the product ID in both tables. Now let's imagine that the marketing team comes to us and they say, hey, we want to change the list price of the product, and we want to change the price from $357 to something like $399, right? So they want to change the price in the source system to $399. So we'll come over here, we'll change the list price, right? So the transactional system here, the source system where we're getting all this information, doesn't track historical information, or it should not. So all we do is we just change the information here. And when we go to load our ETL that night, we do a comparison and we notice that the price has changed. So now we need to enter a new record here. So I can copy all of this information here, make sure it's consistent, and then I can type in the new price. Now you can almost immediately see there is a problem here, right? Because this is my primary key column, and now I have my product ID is now duplicated in this column, which means I'm going to violate the constraint that's on that column. So now this kind of poses a few different problems for us. In other words, how are we going to handle the fact that this column is no longer unique? How are we going to handle that this column is no longer unique? Are we going to create a composite key, which means that the uniqueness of this is now product ID plus list price? You could do that, but it's probably not, it's definitely not the best option, because later on in this process of loading our dimensional model, we have to store something inside of our inside of our fact tables that tells us which record in the dimensional model is related to that. And we definitely don't want to have to store multiple columns in our fact table for one record. Somebody here has a question on how can we do the comparison and figure out if an attribute has changed. So Albert, that's a really good question. There's a couple different ways you can do that, and it looks like we got a couple minutes here. If you're loading your process at night, what you would do is you'd bring in the record from your transactional system here. You'd bring in your product ID. You would compare that against the price of your dimensional table. So you bring in the data from your source system, you bring in the data from your dimension table, and inside of your SSIS package, inside of your ETL, you can do a comparison. Now, you could do a checksum. We don't typically use checksum here because you get more collision. We typically use hash bytes because you get less collision and a little bit more accuracy. But if you're only comparing one column to one column, I wouldn't use checksum or hash bytes. I would just do a comparison on the column itself. So if you would like, just send me an email after the webinar, and we can have a little bit deeper conversation on that. All right, but that's a really good question. All right, so back to this here, but you can start to see a problem immediately with this dimension table, right? Because I have all these product ID, essentially I've violated the key constraint. So let's fix this. Let's go ahead and add in a product SK here. The SK stands for surrogate key. A couple characteristics about this. This is going to be an integer value column. And now this is my new primary key, which really I should have just copied over from here. So let's copy that over. And then this is my natural key from the source, but it's no longer my primary key. And then every time we add a new record in this table, it just gets a randomly generated, not really random, but it gets in a system-generated identifier that it increments by 1. So it starts with an identity of 1, and then it grows by 1. So it goes from 1 to 2 to 3 to 4 to 5 to 6, so on and so forth. And this value, once again, has absolutely no relationship back to our transactional system where we're getting all this information from. So now you can see how just simply having the surrogate key here is going to solve the problem of having historical information, because since this is the primary key, I can keep making changes to this product over time and keeping historical information without it violating my primary key constraint. And now when we go to load our fact table and we do a lookup based on the key, what we will load into our fact table now is this integer value instead of having to load, you know, a combination of columns or a column here that could change in the future, which we're going to get to in just a moment when we talk about insulating us from source changes. A couple other characteristics about this table, going back to just talking about dimension architecture here, is we would typically have something in here like a start date column and an end date column. You would have to have something in here if you're going to have a slowly changing dimension. And you might also have an active flag or an is current, you know, is current or is active, something like that. And then for the first record here, this was the first price, so we could do something like 1/1/2017 until, let's say, 3/1 of 2017. And then when we started the new record on 3/2, we'll give that a start date, and then we might give that a value of null. Now, a lot of companies won't use a null value here. What they'll do is they'll put in something like a date in the future, like 1/1/2099, and then they'll just update that once they expire that row. And then we'll come in here and say, this is my, that's no longer active, and this is my active record. So it'd be something like true and false. All right. So that is what the dimension is going to look like when we kind of structure this for those type 2 dimensions. And now you can see why we want to have those surrogate keys in place in our dimension so that we can track changes over time. Oh, my date's incorrect. You're correct. I didn't know I put an 8 up there. Thank you. There's a lot of questions coming through, so it's hard for me to kind of keep up with all your questions, but I promise you that after the webinar, I'm going to get as many questions as I can answered on my blog. And then, of course, the video itself is recorded, so you can go back and watch it as many times as you want. All right, so that's one example here. I'm going to go ahead and duplicate this again, and I'm going to talk about insulating you from source changes here. All right, so insulating us from source changes. Now, this was a big problem a few years ago when you had all these banks that were going in there and they were acquiring other institutions, because when they acquired them, they would have these kind of business keys inside of their dimensional models that needed to change. And when you have to go in there and change something like the business key, and if that's a primary key in your fact tables, it's going to cause some major problems. So let me walk you through that real quick. All right, so once again, this is our source system. And then this is our dimensional model. All right. The other thing we're going to have to build out here for this to make sense is we're going to have to just kind of draw a fact table real quick. So our fact table is going to have a few columns here. We'll give it a product ID. We're going to give it a customer key. And then we'll give it a date SK. And let's go ahead and give it an amount and a quantity so we have some measures in there. All right. So we'll give it a product ID. We'll still the one we got here. The customer key will be something like 5467. We'll give it a date of March 1st, an amount of 300, and then a quantity of 1. And I guess the price is $3.99. All right. So here's the problem that we have whenever you have source changes in your source and the impact that it has on your dimensional model. So here's what we'll do. We'll go into our product ID, and let's say that somebody in the transactional system, they decided that the product ID that we're using just doesn't work for us anymore, and we need to change that. So they go in there and they change it to something like PD-8743225. All right, well, the first thing we need to do is we have to come into our dimensional model, and we have to update the product ID in our dimensional model. That's typically not that difficult of a process to do, because when you go in there and you update it, you might only have, let's say, 10,000 records or 100,000 records. Maybe if you have a large dimension like a customer dimension, you have 1,000,000 records. doing an update on a dimension that has 1 million records really isn't that intensive of an operation. That's something SQL Server should be able to handle pretty easily. So we say, okay, this is great. I'm going to come in here and I'm going to update my dimension table. Obviously, we have to figure out how to map that, which is part of just the ETL process. But the problem that we run into is when you get to this fact table here, this transactional fact table, and you need to update it. Because right now, I cannot take this PD-874 and put that into my fact table because this is an integer value. Remember that our original column that we have from our source system was an integer value, right? Integer value. So now we have to change the data type of this fact table. I've worked for clients that have had fact tables as large as 350 billion rows. So if you have a fact table here that has 350 billion rows in it, you can't come in here and say, oh, well, we need to go ahead and change. And this is a tip for everybody. Never, ever do this. Don't go into a fact table that's large or any table that's large and just change the data type, because that could essentially crash your system because it makes a copy of the data in the background, it rewrites it all. It's a very intensive operation, so you got to be really careful with that. If you run into this problem here where you get to your fact table and you cannot update the product ID so you can store the new alphanumeric value into your fact table, then this is going to be a very high-level conversation you have to have with the business to figure out how you're going to proceed to go forward. In the past, we've had to do things like add an additional column over here, and we migrate the current one over to that one, and then we insert the new records into this one as well. So we just update it. Or we've created new tables that have the correct data type, and then we migrate this table over to the new table over a period of weeks throughout an incremental process where we slowly update that over time. But this is a very real business process that a lot of operations run into because they don't have surrogate keys modeled into their dimensional model. So this is a problem you have to look at. So let's step back a little bit. Hopefully this makes sense, everybody. You can't put this product ID into this fact table during the ETL process. So let's step back. I'm going to go back and I'm going to change this. I'm going to make this back to its original value. I'm going to come back into my dimensional model here. We're going to add a product SK like we did before. We'll give that column a value of 1. We'll move this over, and then this is my natural key. And then let's left align that real quick. All right. So now what happens is when we load our dimension using the product SK, which is a best practice anyway. And then when they come in here and they say, we're going to change our source system, and they change this from 8743225 to PD-8743225, then what happens is I can come in here and update my dimension as well. So we'll come into our dimension, PD-8743225, and then notice that there's no reason for me to make any changes whatsoever to this fact table because the fact table is now insulated from those changes in the source system. Because I'm storing the surrogate key, which has absolutely no relationship to the source system, we're simply using that for my joins back to my fact table and for historical changes and to insulate us from source changes. We now are protected from this. So this fact table here that has 350 billion records, we don't have to make any changes to it whatsoever because now we're insulated from those changes because we're using the product SK to go back to the product dimension and get those attributes. All right. So yes, so somebody had a question here about now the natural key has changed in the dimensional model, and that is correct, and we would have to change that in the dimensional model. The good thing about it is typically, remember we talked about characteristics of dimensions earlier, dimensions typically have less records than fact tables. So you might only have 10,000 records or 100,000 records in a dimension, whereas a fact table is going to have, I've worked for clients, you just have hundreds of millions or billions of rows in a fact table. So making that change in a dimension, significantly easier than having to go and make that change in a fact table. So, unfortunately, surrogate keys really aren't going to insulate us from those changes in the dimension all the time, but it's going to definitely protect us from having to rewrite our entire fact table and reload everything. All right, so good question. Let me see if there's any other ones I can answer real quick. Yes, so you are correct. Albert said that for our previous example up here, that a lot of times a dimensional table will not have an active flag because the end users know to query it based on either the end dates that's null or the end date that's 1/1/2099, which means that is the active record. So sometimes you'll see this in dimensional models and sometimes you will not. All right, so Sue had a great question. Sue, let me see if I can answer this for you really fast from a high level. This is another benefit of surrogate keys. So Sue's question was, when two different sources have two different natural keys for the same product, how is this handled? This is a very real problem for a lot of businesses because marketing has one way that they call a product, and then you have another, like your manufacturing has a way that they call the product, right? So we're pulling from two different source systems, and we have to combine that. So what I'll do here, Sue, is I'll actually add an additional column into this, and this might be my product ID from marketing, and then this will be my product ID from, my product ID from my manufacturing. Manufacturing here. All right, let me expand that a little bit. So then product ID from manufacturing might be something like XYZ, 76432. So that whenever these two different departments decide they're going to do analysis from the fact table to the dimension, they still do the join on the product SK, but then each different department, as they're doing their reports and doing their analysis, they would use their own kind of product key that they're used to looking at. So what you would do, Sue, and this is very quick, very high level because of just time constraints, but what you would do here is typically you can add that additional column to your dimensional model where you have two separate natural keys, each that tie back to their original source system. So one for manufacturing and then one for your marketing department. So that's a good question. If you have more questions on that, please feel free to email me after the webinar and we can get into some more specifics around that. All right, good question. Okay, so we're going to jump back into PowerPoint real quick. So this is a really cool concept around mini dimensions, and my guess here is that a lot of you probably have not heard of a mini dimension before. There's some caveats to it, but there's some benefits to it. So typically what happens, especially in a dimension table, is if you have a lot of slowly changing dimensions or a lot of columns inside of a dimension table that could change and you're going to keep historical information for that, then what you'll do is you'll expire that record and then insert a new record. And that could be very difficult to maintain over time. So for example, let's say that I have a dimension table that has 10 million rows in it for my customers. And when we designed it, we didn't realize how fast that table was going to grow just from historical changes. So now Mitchell Pearson, for example, he's changed his marital status and he's changed his number of kids so far this year. And we track those historically. So now he has 3 records in that table instead of 1. So at the end of the year, instead of having 10,000 records or 10 million records inside of our customer dimension, we now have 30 million records inside of our customer dimension. All right? And Albert said, congrats on the children. Thank you, Albert. So we now have 30 million records in our customer dimension. And you could just notice that over time it's going to grow and grow and grow and grow out of control. So one of the things you can try to do is you can use what's called a mini dimension to move all of those highly volatile columns to their own mini dimension. All right? So what we do is we take those attributes out of the customer dimension or whatever dimension is we're looking at. So if they're married, how many kids do they own, how many bikes do they own, how many cars do they own, any of those things that impact our business that we want to know about that could change, a lot. We take those and we put them in their own mini dimension and we remove them from the original dimension. And I'm going to model this out in a minute so it'll make more sense to you guys. The new dimension is not a snowflake of the existing dimension. It's actually a new dimension in and of itself, and it has a direct relationship to the fact table in the middle. This is primarily done, once again, to help with the just growing of your slowly changing dimensions to where they grow out of control over time. All right? Okay. So we had a question here. I want to clear this. There's so many questions coming through. There's a question here about, so the surrogate key is only needed for type 2 dimensions. No, I would recommend that you put the surrogate key in there for all of your dimensions, type 1, type 0, type 2, even if they don't have historical changes, because 1, it still insulates you from source changes over time. 2, it's typically going to help you with things like optimization of query joins, since you're always joining on those integer values instead of the natural key from the source as well. So there's a lot of different reasons why you want to do surrogate keys that we can't cover just here. But yeah, I would definitely do surrogate keys on all of my dimension tables, not just the ones that are tracking historical changes over time. All right, so let's do another quick demo here, and we're going to look at first, what does a mini dimension look like? So what happens here when you're modeling out the mini dimension is, and it's mini as in M-I-N-I, is you take all of the attributes. Now one characteristic of this is it has to be attributes that have a low cardinality or attributes that don't have a lot of unique values. And the reason for that is because you're really going to create a Cartesian product across all of these different attributes. Now, something you're probably more familiar with than many dimensions is a lot of you are probably familiar with junk dimensions, and that's what a junk dimension is. It's a Cartesian product of all of these low cardinality columns that had nowhere else to go, so you stick them all in one table. Well, this is very similar in the way that you structure it. So, for example, if I have a flag here for is married, so are they married or not? Well, I have to have one record in here for if they're married, how many children do they have, how many cars, and how many bikes. So if I'm married and I have 0 children, 0 cars, and 0 bikes, then I get assigned a customer demographic key of a 1. If I'm married and I have 0 children, 0 cars, and 1 bike, then my customer demographic key is 2. So on and so forth. So you would just go down the list here. So you would say 3, 4, 5, and whenever we go through our ETL process and we're loading our fact table, we determine the customer demographic key based on their current status, right? So at this time and place, are they married? How many kids do they have? How many cars do they have? And how many bikes do they have? So this is a mini dimension, and we would go back to our customer dimension and we would remove those attributes from it. Now, a lot of times I'll create something like this in Excel, and then I can use some expressions here to generate the code that I'm going to essentially put into T-SQL. So now I can just copy out this entire dimension and I can create the new table and insert it into T-SQL, or insert it into a SQL Server. So the next thing I want to show you guys is how to kind of model this out real quick, and we're going to use Management Studios for this. So I have 2 tables here. I have a dim customer table and I have a fact transaction table. We've removed all of the other dimensions just to kind of simplify our use case scenario here. And what I'm going to do is I'm going to create a new, inside of this database diagram, I'm going to create a new table here. And this new table is going to be a dim customer demographic table. And then click OK. And then we're going to insert some new columns here. So let's go with our surrogate key. We're going to add this on every one of our data models that we, or every one of our dimensionals that we build. I'm going to add in a married column here. That's going to just be a Boolean value. Let's go with number of children. Now notice that all of these attributes that I'm bringing in are all coming from our dim customer table. So number of cars, integer value, and then something like number of bikes. What's really interesting about this is that when somebody changes, so imagine you're talking about Mitchell Pearson again, and I go from being married and I go to being single. You don't have to expire a record in this table anymore, because what we're going to do is we're going to come to the customer table and we're going to delete all 4 of these attributes here, because we no longer need to track them here, because now we're tracking them in this new table. So I'll make my demographic key a primary key. We would go in there and we would have to make this an identity column real quick. So let's make that an identity column so it just automatically increments by 1. And then I would create, we need to go into our fact table and we need to add that key into our fact table. So remember that once again, this does not have a direct relationship to our customer table. Let's see here, we'll call this our customer demographic SK, and then I'll add an integer value here. We will not allow nulls. There we go. So let's change that back to columns. And now I can create that foreign key relationship here real quick. And now this is what your data model is going to kind of look like here. Let me go ahead and put that in a column only view. There we go. This is what it looks like now. So there's no relationship between customer and dim customer geographic. Now there is this concept of outrigger dimensions that we don't have time to talk about. So technically you could track whatever the latest customer demographic SK is here. So if you ever wanted to look at your customers, you could go directly from this table to that table where you have a relationship between the two. But we're not going to do that here. We're not going to talk about outrigger dimensions. Now what's cool about this is that if Mitchell changes his marital status or number of children or number of cars or number of bikes, we don't have to expire a record here, and this dimension does not grow out of control. It stays at 10 million. It doesn't grow out of control. We don't keep adding new records every time something changes. All we do is inside of the fact table here, let's see if I can just draw this out very quickly here. Inside of the fact table, you'll have records. So let's say you have customer SK, and then you have the demographic SK here. I'm just going to do this. And then you have, you know, a sales amount, whatever. All right. So the first time I make a purchase, my customer SK is 1. My customer demographic is 1 because I'm married, no kids, no cars, no children. And then I purchase something for $5 and whatever the product was. You'd have all those other attributes there. The next time, excuse me, that I come by and make a purchase from the store, I would come in here and my customer SK has not changed. But my demographic SK has changed because now I have 1 kid or 1 car or whatever it was that changed. And so now when I do a lookup to that table, the value changes. and now my sales amount, I purchased something that was a little bit more and it was $6. There's two things to watch out for here. One, it's great because your dimensions don't grow out of control, all right? There is a major problem with this though, and the problem is that it does not track demographic changes over time unless the customer made a transaction, because now the relationship is only being stored in the fact table. The relationship only exists in the fact table. So here's an example. Imagine that, where's that mini table that we had earlier here? I can't bring it up real quick. Imagine that I got divorced, all right? I got divorced and then I got married again. And I was divorced for a period of 2 years. If I never made a purchase from your company during the period of time that I was divorced, then you have nowhere inside of your dimensional model that tracked that the reason I stopped making purchases from you was because I was divorced. It's not tracked anywhere in your table because you don't have it tracked in your dim customer table anymore. When you do these many dimensions, the relationship is stored in this bridge table, in this fact table here, and that means it only tracks changes if a transaction occurs. However, if we were doing it in a customer table where we were tracking changes over time, even if they didn't make a transaction, so we sent out surveys and they filled out the surveys, we would know, hey, on January 30th, Mitchell got divorced, and we can see that over the last year, for whatever reason, since I was divorced or since the number of cars I had or bikes or children, whatever it is that we're measuring, since that attribute changed, I actually stopped making purchases from y'all. So you lose a little bit of analytical value there because I want to know that, hey, as people buy cars, they stop purchasing from us. Maybe we're a bike selling shop, right? The more cars somebody owns, the less they purchase, but we don't even know how many cars they have because we only register that information at the time of purchase through the customer demographic table. So just from a high level, understand that that is a caveat of this. I really can't go into more details here because I want to jump into the next demo and talk a little bit about kind of modeling a many-to-many relationship for you guys. All right, Sue had a question here, but we load customer demographic based on customer SK though, right? Technically no, Sue, not in this example. In this example here, you just look up the attributes of the customer and then you get the customer surrogate demographic SK from that. So you don't need the customer SK here at all when you're loading that table and getting the SK. All right, there's a lot of questions here, so I can see I'm going to be busy all night tonight answering questions. All right, so we're going to talk a little bit about relationships, and I'm going to go through this quickly. Remember, it's recorded for you guys. So the first one here is one-to-many relationship. This is your typical relationship that you're going to see inside of a dimensional model. You're going to have one-to-many relationship, which simply means that there's a relationship between two entities where A and B are the entities, and each element of A may be linked to many elements of B, but a member of B is linked to only one element of A. All right, so an example of this is like a product table and a fact table. A product table is a one side of the relationship because every single product only shows up in my product dimension one time, or the surrogate key itself is a primary key, it's unique, but the product key can show up in the fact table every single time a customer makes a purchase, right? So it's it shows up in the fact table many times, it only shows up in the product table one time, so it's a one-to-many relationship. And I'm not doing this relationship justice, but that's what that is. A many-to-many relationship is where you have two entities and there is a many-to-many relationship between them. So for example, if I were writing a book, and I've actually never written a book, but if I were to author a book, I might write a book on SSIS, so Introduction to SSIS or MDX or something like that. And I might have somebody who actually helps me write that book. So Dustin Ryan, who's an expert at MDX, might come over and say, hey, I'm going to help you write this book. And I'm like, oh, this is awesome. So two authors could write a single book. Well, an author can also write multiple books, right? So I could write a book on SSIS, and I could write a book on MDX and T-SQL and so on and so forth. So when you're looking at this here, if I was going to kind of draw this out, you could have something like, author SK, which is Mitchell, so that would be 1, and then let's do something like 2 here. And I'm going to draw this out. I should just put names, actually. Let's do names. So we'll do author. So Mitchell writes the book, and then, Dustin Ryan helps, and then maybe I write another book later on, right? So you have an author, and then you have the books that were written. So I write a book on MDX, Dustin helps me write a book on MDX, and then I write a book on SSIS. So you can see here the relationship between the two. There's a many-to-many relationship because an author can write many books, and a book can be written by multiple authors. So there's a many-to-many relationship. You cannot author this or create this in your dimensional model without having some type of bridge table that stores this relationship. And you can kind of see that down here below. The way that we typically author these, or the way that we typically implement these, are either through bridge tables that we create or through just fact tables that exist. So fact tables are commonly referenced as a many-to-many bridge, and the reason it's referenced as a many-to-many bridge is because it stores the relationships between those many-to-many relationships between your dimensions. Now this is a much bigger topic. Like I said, we could spend an entire class on just many-to-many relationships, but that's what this is here. So what we're doing is we're creating a bridge table in the middle that simply stores the author ID and the book ID. So every time I write a book, that record gets entered into this bridge table here with my ID and the ID of the book. And if I ever want to get a list of all the books that I've written, the name of the book, the genre of the book, the description, I would have to go through that bridge table and then retrieve that information from the dim book table. I'd have to go through that bridge table that we created. Now this is just a basic example of what a many-to-many relationship is. Now we're going to get more into dimensional modeling and how this impacts you guys from a high level. So let's imagine, for example, inside of your organization, you're selling a bunch of different products. That's what your business is, selling products. And you have a bunch of different promotions that you have throughout the year. So you have promotions for Black Friday, you have promotions for Memorial Day, and then you have promotions for New Year's Day. A promotion, right, can be for multiple products, so like mountain bikes and road bikes, or mountain bikes, road bikes, and helmets, which those are really categories, but this is just a quick example here. And a product could have multiple promotions, right? So mountain bike is a promotion, has a promotion of Memorial Day, and it has a promotion of Black Friday. The way that I've modeled this example, I'm going to show you two different ways to model this. The way that I've modeled this example here might be the first way that you would think to model this relationship. Just go ahead and use the fact table that exists and use it as a many-to-many bridge between your two different dimensions. So inside of this fact table, I have both the promotion, if there was a promotion that was used for that product that was purchased, and then I have the product. So this is an easy way to model it, and this is probably where you would normally start. Now there's one problem with this, and this is the same problem that we had with the mini dimension example I told you about a moment ago when we were talking about kind of simplifying the slowly changing dimensions, right, so we could manage them over time. The problem here is that the relationship between these two tables is stored in the fact table. So let's say that I have a promotion for road bikes, right? So road bikes is part of the promotion for Black Friday. How do I know if that's a good promotion or if that's a bad promotion? The way that I know that is I go and I look at the fact table and I see how many road bikes were sold for that promotion, right? Well, what if no road bikes were sold? What if I have a promotion for Black Friday and road bikes was on that promotion and we were selling them at 20% discount, but nobody bought our road bikes? There's a problem with the way that we're modeling this, and the problem is that we're not storing that information anywhere. The way that I know what products were on promotion is by going to the fact table, right? Because that's where we're storing the relationship. The relationship is stored right here in the fact table. So if nobody purchased road bikes, all right, hopefully this is making sense here. If nobody purchased road bikes during that promotion right there, then we have no idea in the future to really do any kind of analysis on it and realize that that was a terrible promotion, because there's nowhere that we're storing that information. So in this example here, it's not what it is showing us, it's what it's not telling us. And it's not storing that information for us to go back and look at, because that relationship is only stored in the fact table if a transaction occurs. So that's a major problem with this kind of model. Not always, it depends on what you're modeling, but you can see with promotions and products that we might lose some information there. All right, so what is a better way to model this? Let's see what time it is. Okay, we got a few minutes. A better way to model this is to create a bridge table, to not use the fact table itself. So there's no measures in a factless fact table or a bridge table. You can use either one as far as terminology is concerned. I prefer to call it a bridge table, but they're also known as factless fact tables, and they're called factless fact tables because there's no measures in them. They just store the relationships. There are a couple different ways to model this. I showed you one already. What we would do here is, here's my fact table just like before. The fact table has a relationship to the product SK, so we know every single time a product SK is stored, or every time a product is sold, we store it in the fact table. The way that we can find out what promotion that product was on is we would now go through this relationship right here to the bridge table. The bridge table stores the relationship for every promotion that we have, and every product that is part of that promotion is stored in the bridge table. So now, if we go and look at this fact table here, we can find out which products were on promotion and then never sold, because we stored it in our fact promotions table. All right, we've stored it in our fact promotions table, so now we can go back and we can find out which ones never sold, which ones were terrible, which ones were kind of terrible promotions that we put out there in the past. So this is just a different way to modeling it. I'm not going to tell you one is right or one is wrong. This is kind of an art that you develop over time, but these are things that you have to consider and think about as you're designing out your dimensional model. Now there's a question here from Connie. Why is it called a fact table and not a DIM? It's called a fact table because you can have fact tables that just store relationships, like things like a student that goes to class, right? So you store just the student and the class. That has it's a fact table because it stores the relationship between a student and a class, and we can go and look at that, and it's something that we want to measure and explain with dimensions. So because it's a bridge table between two different dimensions, it's called a fact table, and it stores exactly. And Albert said because it stores the foreign keys from the dimensions. Yep, because it's a dimension. But it's just the terminology that's used there. A lot of people don't even call it a fact table because it can be confusing. They just call it a bridge table, so bridge promotions. All right. So I kind of have to end this here, but I wanted to get to this, and I did. These are your two different options for that scenario. There's other options for many-to-many relationships as well. So that's one way of storing that. But this is good because if I put something on promotion and it doesn't sell, now I can compare my fact promotions table with my fact sales table. I can quickly and easily identify which products didn't sell when they were on promotion, and we can use that with our marketing team to do a better job in the future. All right? So a couple things about why you don't want to use these bridge tables, or a couple considerations here. One is they're not supported by all client applications. Two, it can decrease query and processing performance. So because now you've added additional joins to your dimensional model, you have to go through those additional tables. It can decrease query and processing performance. It will complicate the ETL process, right? With the ETL process, you're going to have to load that dimension table, and everything's going to have to match, and you're going to have to know every single time a list of products go on promotion, you're going to have to load that into the bridge table, so that will complicate it. There's also a concept of double counting that can occur, which is very important, and you have to know how to allocate that and how to handle that in your model. Something that we cover in the class, but I just don't have time to cover here. All right? There's some questions in here about the promo code and how to use it. If you want to use this promo code, the best way to do that is probably, I don't think there's a place on our website to do that because we don't like to put them out there so everybody has access. So Liz, what's the best way for them to do that?
For the promo code, you just need to go to our website, and when you add either the data modeling class or the Elite package to your cart, once you view your cart, you will have the option to put in a promo code, and you just simply put data modeling in that promo code section and hit apply, and you'll be good to go.
All right, so there is a promo section there. Excellent. Okay. Yeah, so if you guys want to do that, or if y'all have any questions, I went ahead and threw my email up there at the top as well. I think I have a couple minutes, so I'm going to try to hit a couple questions here, and then I'll also try to answer as many as I can in the blog. We've done these data modeling sessions once before on the webinar, and I've done them in person at SQL Saturdays, and every time there's standing room only and just tons of questions. So I know there's going to be a lot of questions here. Let's see, Jennifer has a question. Should there be a link between the fact sales to the fact promotion? So yes, there is a link, but it's going through the product table. So you have to go through the product SK to the product table, and then from the product table to the bridge table. So there is a link, but it's not a direct link. It's one that you have to go through those two different tables, which is why it can decrease query performance, especially as they get very large over time and query performance. All right, let's see. So it does require a change, but there's a lot of comments in here along with questions. So let's see if I can answer one or two more. Oh, okay. So Ronald had a question here. Is the surrogate key always defined in the data warehouse database, or can you define it in the SSAS model? So you can definitely do it in the SSA, in the model, either through the data source view or through a view that you create when you bring the data in, but I would highly recommend that you do it in the dimensional model. So maybe you're in a situation where unfortunately it wasn't created at the beginning, but you realize that it's going to optimize the joins inside of analysis services. You're going to get better query and processing performance, so you want to add them in there. Then Ronald, you can do it at that point, but from a high level, you absolutely would rather do that earlier on in the process. You want to do that in the dimensional model so that you know, it doesn't change, right? But yeah, you could do it there as well. All right, Liz, I think that's good for now. There's a lot of questions here. If you could send those over to me when you get that. I know you got to download everything. And once again, if you guys are interested, Liz will send out a follow-up email with the blog once I post that, which will redirect you directly to pragmaticworks.com.
Yep. Thanks, everybody, for joining us today. Again, as Mitchell said, you can email him if you have any questions. You can email me, Liz. It's the email that comes with all your GoToWebinar information. I'll be happy to pass along any questions that you may have. As always, this session was recorded, so you'll receive an email tomorrow with the link. I'll also be sure to include the promo code in there in case you need that again as well. And thanks again for joining us, and we'll hope to see you in a future session. Thank you, Mitchell.
All right. Thank you, Liz. Thank you, everybody.